Solving logarithmic equations, there's two ways this is going to happen. You're going to have log equals log, or natural log equals natural log, or you'll have log or natural log equals a number. When you have log equals log, you can drop the log and solve the resulting equation, which is what you have in number 29. So log base 4 equals log base 4. Drop those and you'll have 5x plus 7 equals 2x plus 31. Solve the equation by subtracting 2x from both sides, and you have 3x plus 7 equals 31. Subtract 7 from both sides and divide by 3. And we end up with x equals 8. But since this is a logarithm, we can't accept that. We have to check it. So let's do math, alpha math, and we'll do log base 4 of 5 times x plus 7. That works. Then over here, should get the exact same thing, log base 4 of 2 times x plus 31. Okay, so works out beautifully, so that's our solution. On number 30, we have the natural log equals the natural log, so I'm able to drop those, and I have p squared minus p is equal to 6p plus 18. So I have a square and a p, that means I'm going to have to factor. So let's move 6p to the other side by subtracting 6p. Negative 1 minus 6 is negative 7p. Now subtract 18 from both sides, and you have p squared minus 7p minus 18 equals 0. So let's list the factors of negative 18. I need opposite signs with my bigger factor being negative. So all of these multiply to negative 18, but only 2 and negative 9 will add together to give me my middle number of negative 7. So my factored form is p plus 2 and p minus 9. Okay, now let's set both of these equal to 0. And let's solve for p. We'll subtract 2 from both sides to get negative 2. We'll add 9 to both sides to get 9. So let's check both of these solutions. We have the natural log of, p squared, so that's going to be negative 2 squared minus a negative 2. Okay, then we have the other side, the natural log of 6p plus 18. So that works out beautifully. So negative 2 is one of our solutions. Now let's check 9, the natural log of 9 squared minus 9, and the natural log of 6 times 9 plus 18. Okay. So both of these are solutions to the equation. Number 31. Before I can solve this, I've got to condense because I've got 2 logs on the left side. So when we condense, we always bring our big numbers to the front. And we get 36 to the 1/2. 36 to the 1/2 is the same thing as the square root of 36. So I get log base 8 of the square root of 36, which is 6, and then log base 8 of 3k plus 7. Pull your log base 8 to the front and multiply 6 times 3k plus 7. Okay, so now you have log base 8 is equal to log base 8. That means I can drop the log base 8 and set these two equal to each other. Okay, so I'm going to get rid of the 6 first by dividing both sides by 6. 3k plus 7 is equal to 22. Now let's subtract 7 from both sides, and we'll get 3k is equal to 15, and then divide both sides by 3 to get k is equal to 5. All right, so we should be able to multiply this. Let's see if we have 1/2 times log base 8 of 36 plus log base 8 of 3 times 5 plus 7. Okay, and that works out beautifully. So k equals 5 is not an extraneous solution. Okay, number 32. Go ahead and bring this to the top, and we'll have the log of y plus 5 squared is equal to, bring your log to the front, and since we have subtraction, we'll have 20 over 5, which is 4. So, since I have log equals log, I can drop the log, and I'll have y plus 5 squared equals 4. Let's FOIL this out. Y plus 5 squared, you have to multiply y plus 5 twice. So y squared plus 5y plus 5y plus 25, which will give you y squared plus 10y plus 25. Just remember, if this happens, you can take the first term and you can square it, y times y. You can multiply y times 5 times 2, because there's 2 of them, to get 10y. And then you can take the last term and square it. Okay, now let's move this 4 over here. And you'll get y squared plus 10y plus 21 equals 0. So let's factor. The factors of 21, same signs, both of them positive. Both of these multiply to 21, but only 3 and 7 add to give you your middle number. So we have y plus 3, y plus 7 equals 0. So when we solve these two equations, we get negative 3 and negative 7 as our two solutions. So let's check for an extraneous solution. So we have 2 times the log, which is your common log, of negative 2 plus 5. That works beautifully. So that's negative 3. So let's try that again. 2 times the log of negative 3 plus 5. That works beautifully. So negative 3 is one of our solutions. Now let's check negative 7. 2 times the log of negative 7 plus 5. Oh, non-real answer, because when you plug in negative 7 plus 5, you get a negative 2. So that tells me that negative 7, while as a solution to the equation, is not a solution to the logarithm. It's an extraneous solution. So negative 3 is the only answer that we can use that'll work there. Okay, looking on the back. Number 33, when you have a log equal to a number, you have to change it to an exponential equation. So since you have base 2, you're going to have base 2 of your exponential equation. So loop around, 2 to the 7th power equals 9m plus 2. Okay, so the first thing that we want to do is we want to evaluate 2 to the 7th power, and we'll get 128. And to solve for m, subtract 2 from both sides. And then we'll divide both sides by 9. Okay, so 126 divided by 9 is 14.